Welcome students. Fifth chapter, I am up and down and round and round. Exercise 5.2 solution. Show that the triangle formed by a chord and a center of the circle is isosceles. So let's take a triangle in a circle. So say this is circle with center O. This is center of the circle O. Then triangle formed by a chord. So we need to take a chord in a circle. You know, chord is the line segment joining opposite points on the circle. So let's take, this is the chord. Many chords, infinitely many chords are there in a circle. Let's take chord AB. If this is our chord AB, A, B is a chord, a triangle formed by a chord and the center. So I said O is the center. Here center O. Now we need to join this and make a triangle. OA, one side of the triangle. And joining OB, we will be getting another side of the triangle. Then the third side is chord. AB is a chord. So now we got a triangle OAB. We have to prove this triangle is an isosceles triangle. So here given very simple question, that is given here. Whenever logic based questions, we need to write given and to prove. Here given AB is a chord of circle with center O, and to prove triangle OAB is an isosceles triangle. That's all. This is to prove. For the proof, since O is the center, we know that A and B are the points on the circle. A and B are 2 points on the circle, and we know that O is the center, which implies OA is equal to OB is equal to radius of the circle. Both are radius of the circle, so OA is equal to OB. So in triangle AOB, OA is equal to OB, which implies angle OAB is equal to angle OBA. Two sides are equal and two angles are, when opposite angle of equal sides are equal, so two sides are equal and two angles are equal. Therefore triangle AOB or OAB is an isosceles triangle. That's all. Isosceles triangle. Two radius, OA, OB are the radius, except the chord, other two lines are, because the line segments from the center to the boundary point is nothing but the radius, so they are equal. So OAB is an isosceles triangle. Next question, show that if two such isosceles triangle occurring in the previous question have equal base length, they are concurrent to each other. So if we are taking two isosceles triangles in the circle, so let's take the circle. Then as usual, O is the center of the circle. We need to take two triangles. So this is one triangle. And one more. Two triangles. Two isosceles triangles. So these are the two triangles we can take. What is given here? Show that two such isosceles triangles. Let's take point O, center point O, and one chord A and B, another chord C, D. Now here given triangle OAB and triangle OCD are isosceles triangles. Then have equal base. So isosceles triangle means in AOB, that is OA is equal to OB in triangle OAB, and OC is equal to OD in triangle OCD. We proved in previous sum. One more information also given in this question. Equal base length. So which is base? The chord is nothing but the base. These are the base. And AB is equal to CD. This is also given condition. We need to prove. What to prove here? They are concurrent to each other. So triangle AOB is concurrent to triangle COD. So they are concurrent to each other. We have to prove. For the proof, take the triangles AOB and triangle COD. Let's check the angles or the sides, whatever it may be, we will check it. What is given? That is in triangle AOB, OA, OB, OC, OD, everything are radius. So 4 radii here you can see OA is a radius and OB radius, OC, OD all are radius. So OA in triangle AOB OA is equal to in triangle COD OC, because they are radii of the circle. And again OB is equal to OD. They are also the radii of the circle. And AB is equal to CD. Why we took AB is equal to CD? Because this is the given condition. The base are equal, it is given. So therefore, triangle AOB is concurrent to triangle COD by what criteria? Side criteria. All the three sides are equal, so that the both the triangles are concurrent to each other. By SSS criteria, two triangles are concurrent to each other. Thank you.